Hello Honors Chemistry students, this is Mr. Spurk, and this is your Chapter 9, Section 1 notes on naming ions. Now this is going to be a bit of a review because we've already talked about ions and such, but what a great way to start the second semester. Alright, so monatomic ions, we already know that ionic compounds consist of a cation and an anion, or at least we should. Please do not forget that. So that's a metal and a nonmetal. And overall, when they balance out, they have a net charge of 0. So naming cations of groups 1A through 3A, we just use the name of the metal followed by the word ion. For example, Na+, we call that sodium ion. Doesn't get much easier than that. But again, this goes back to you understanding and knowing the names of the elements on the periodic table. Remember that there is that Quizlet out there if you're still struggling with that. This chapter is all about that. Let's go to anions. Their names start with the stem of the element name and end in IDE. So N3- or nitrogen becomes nitride. We cut off the OGEN and it becomes nitride. O2-, we know that element is oxygen. So again, we cut off the ending and we change it to IDE, oxide. Metals that form more than one ion. So what we have to do here is name the metal with a Roman numeral that represents the charge. Remember, these metals that form more than one ion are our transition metals, which are our D block elements. So, and the Roman numeral represents the charge. So for example, Fe2+ is named iron, and then the Roman numeral 2 must be in parentheses. So I don't want to see the number 2. It's got to be Roman numeral in parentheses. And Fe3+ corresponds to iron 1, 2, 3. Iron 3. So the charge is represented by the Roman numeral. Now there are also Latin names, and these we won't discuss too much. I just want you to see them because you may see them maybe if you're looking something up online. So when using the Latin name, you write the root word with different suffixes to represent the charges. So iron, remember we've talked about why they are not the symbols, like a two-letter symbol that really makes sense. So iron is Fe. That's because it used to be called ferrous, and ferrous represents 2+, and ferric represents iron 3+. So we see this a lot, like tin is Sn, and so its roots for tin 2+ are stannous, and Sn4+, so the one that has a higher oxidation number, is stannic. And again, we aren't going to discuss those too often, but I do want you to at least be familiar. If you ever see these somewhere, you can at least understand what they're talking about. So there are a couple exceptions. A few transition metals only have one ionic charge, so they don't need the Roman numeral. And if you include the Roman numeral, that is incorrect. So for example, silver is a D block element. It is a transition metal, but it is always Ag+1. So we never write silver 1. It's always just silver. Same goes for cadmium and zinc. So you need to remember these three. You need to know their symbols, their charges, and that they do not get Roman numerals. Last thing we're going to talk about is the polyatomic ions. We have briefly talked about these. Here is a large list for you. These I do need you to be familiar with. We also have a Quizlet there. We need to be very familiar with these as we move forward. Sometimes the same 2 or 3 elements combine in different ratios to form different polyatomic ions. So you have to pay attention to the number of oxygens. So you have to learn the polyatomic ions first and then focus on the changes to the names when the ratio is different. So for example, if we look at sulfate and sulfite, sulfate is SO4 2-, and sulfite is SO3, 2-. So the charge stays the same, the root stays the same, but the ending is different based on the number of oxygens. So the charge is the same. The ending does not tell you the number of oxygens. So if you look at this, so here we had sulfite, SO3, but if we look down here, nitrite is NO2. So the ending does not tell you how many oxygens, it just tells you is it more or less. So you must know the common polyatomic ion. And that's what I have written in bold here. These are the common forms. So more, for example, nitrate is NO3, and nitrite, remember ITE implies less oxygens, so NO2-. Again, their charges have not changed, just the number of oxygens. The last one that we do run into is when there are 4 different forms. So for example, here we have chlorate. So you need to know that chlorate means ClO3-. And per-ate, so per-chlorate, implies 1 more oxygen, so ClO4. And then as we go down the other way, we already know that ITE means less, so ClO2. And then here we have a prefix as well. Hypochlor is our root, and then ite, ClO-. So even 1 less oxygen here. This does get a little tricky, but we will get lots of practice. Honestly, the flashcards on Quizlet are your best bet. So, polyatomic ions. When the formula for polyatomic ions begins with hydrogen, you can think of the H as representing the hydrogen ion combined with the polyatomic ion. For example, HCO3- is a combination of H+ and CO3 2-. Note that the charge on the new ion is the sum of the ionic charges. So we took H+, we added it to CO3 2-, and we get HCO3 1-, because positive 1 plus negative 2 is negative 1. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a great day.